Hey folks, so we're doing a bit of a history lesson today, or a story of history, right? It's a bit of a special edition of an episode. We're going to be covering the history of Unix, right? And the impact that it's had, and the reason why we've all got jobs in tech today, to be quite frank with you, right? It was something that I was thinking about doing for a couple of months, like how we were going to stage it, how we were going to build it out. I've learned a lot researching this. It goes back, all the way back to the late 50s and 60s, but we'll get into that shortly, right? But, it's really spearheaded some of the development practices and the hyperscalers and the cloud platforms that we use today. So I needed some help, and I looked up in my address book, and I was like, who loves Linux and Unix just as much as I do, right? It's one of my favorite operating systems. I thought I'm going to reach out to my favorite Quebecer, Maxime Roy. Maxime, how's it going, dude?
Hey, Kevin. I'm great. And you?
Yeah, I'm good. It's minus 16 here in Alberta today. A lot of snow this week. A lot of snow. It keeps me fit, right?
Yeah. Honestly, shoveling is quite hard on the body, so you need to take care of yourself for that.
Totally. So we're going to go through this. We're going to try and make it as entertaining as possible, right? We're not looking through the archives, right? There's a bit of a storytelling motion to this. Hopefully you get some information out of it, and I hope you walk away and you the penny drops. You'll hear something, you'll be like, we do that every day, right? In the process or a deployment, or I didn't even know, right, that it had this downstream effect, right, on something that I do every day. We're going to try and do one on Windows in the next year because, as you well aware, a lot of us work at Microsoft in some shape or form, right? And the team's excited about it. A lot of history there, a lot of excitement. So let's get this show on the road and let's get things kicked off. Part one, from moonshot to minimalism, Multics, Unix, and the first branches, right? So we're going all the way back. This period of time is between 1965 and 1980, right? So I'm happy to say this is before I was born, and I just found out that Maxime is even younger than me. I'm starting to become the older head on the team, right? But close your eyes and picture this. It's 1965. Computers aren't on desks. They are a desk. They fill entire rooms, humming behind glass walls, guarded like crown jewels. And at MIT, a group of visionaries huddled around chalkboards of dreaming something radical. Computing as a utility, always on, always available, as reliable as electricity. So can you imagine that, right? Going back to that time. And this is stuff that we take for granted now, every day, right? It practically runs planet Earth, right? In terms of the way we do business, the way we, for medical stuff, the way we have entertainment, the way we travel, everything is situated around those concepts, right? So that dream becomes something that's called a project called Multics. And that stands for the Multiplexed Information and Computing Service. It's a bold, beautiful, and destined to change everything, even if it fails. I'm already getting snippets of DevOps practices here, right? It sounds like all of this kind of stuff, fail fast, right? And everything else in development terminology has been originating here. So Multics, the moonshot that sparked the revolution. So Multics wasn't just an operating system, it was a manifesto. Okay, so built by MOT's Project Mac, and it was short for Multiple Access Computer. It also included Bell Labs, which we'll go on to, right, on who each of these companies are, and General Electric, so GE, right? Everyone's heard of GE, I hope, right, on this podcast. They were a huge manufacturer after World War II. They built all your household goods in your homes in North America. And most recently, they're more of a finance organization, right? But again, from an innovation point of view, these are all big American organizations that basically create a beachhead, right, for these computer platforms, right, in the early days. So effectively, right, this multiple access computer, it promised a future where dozens of users could share a single machine interactively. So forget about punch cards, overnight jobs. I mean, that's still happening today, right? Some of our cloud platforms, but Multics aimed for real-time computing, right? So we introduced ideas that feel modern even now, like hierarchical file systems, segment memory, dynamic linking, and security rings. These concepts echo in every OS you've ever touched, right? And used today. I mean, what do you think about that, Maxime? I mean, those are like the corner pillars, right, of pretty much every piece of software or platform that we use.
Exactly. Everything is still, even in that time, is still compute, memory, storage, networking at some point in the future.
Correct.
But yeah, even the small device that we have here, it's all the same.
That's right. The cell phone.
We'll get to that later on.
We're going to get to that. We're going to get to that, right?
But even at that time, if it's been many years, and yeah, it's still compute, storage, the CPUs, the way, everything. It's still the same. It's crazy.
But here's the kicker. Multics ran on hardware that looked like something from a sci-fi movie. I love a sci-fi movie, by the way, especially the older ones. So the General Electric 645 mainframe, I mean, what a catchy title as well, right? I mean, Apple, you need to stand back on this one, right? With marketing like this. And later the Honeywell 6180. So imagine cabinets of core memory, tape drives. I mean, my first job was the backup tape guy, right? So I understand this well. Tape drives spinning like film reels and generalized I/O controllers that could swallow your living room. And we've got a picture here, right, of GE, the 645 system. And the only thing I can sort of describe it as is imagine a large room, maybe, I don't know, 1,000 to 1,200 square feet, full of cabinets and tape drives and tape reels, and it's something that looks like a typewriter in the center of the room as a console. These were vast amounts of storage that probably weren't very big in volume either, right? We're talking bytes at this point, right? Potentially, not even megabytes. So these were like the first data centers, right? But they were R&D labs inside of these companies or at universities, right? Serving computer time, as they would call it. I need some computer time, right, to run analytics or translations or whatever it may be. It was brilliant, yes. Practical, not quite. So complexity slowed progress, costs soared. Sounds very familiar. And by 1969, Bell Labs pulled out, right? So Bell, right, if you don't know who they are, was effectively it's AT&T, right? And they were one of the biggest telecommunications companies, and they still are to this day. I think they're known for different things these days, but back then they were like pioneering this stuff, right? So if we think about networks, telecommunication systems, mass compute, but the frustrations did not kill the dream. It lit a fuse. So who are Bell Labs? So they had a role in Multics and Unix, and Bell Labs collaborated with MIT, so MIT being the famous university, a Project Mac, and General Electric on the Multics project in the 1960s. So it sounds like there's two projects going on now, right? We got Project Mac, we got the Multics project. Although they eventually withdrew due to complexity and costs, that experience inspired their team, Ken Thompson, Ritchie, and others to create Unix in 1969, which emphasized simplicity and portability. Sounds like a piece of technology that we use today a lot, right, in cloud platforms. But could you imagine, Maxime, like 1969 is when the first revision or branch or whatever you want to call it of Unix was like developed?
I think that one of the elements that is fundamental to any computer is running right now has started in those years is crazy to think. It's been what, 50, 70 years approximately?
Absolutely wild, right? To think about it. All the way back
It's
then.
crazy. And also, one thing that I do love to see and hear about what you mentioned is the fact that even if they were doing projects, they were doing research, even if the funding was cut off and the project were abandoned, then it brought something else. That's why it's important to do proof of concepts, trying to get better. And we saw those principles even there, and still applies today.
I totally agree. It was for the love,
Yeah.
right? And some of the best pieces of technology that were ever invented, created, developed were passion projects, right? Collaboration, working with your friends, right? To develop and create something. And we've all been there. I know as a teenager, I did multiple projects on the internet, right? And like, it just drives passion and energy, right? So, but yeah, like here's some of the other major contributions that Bell have done. So they invented the transistor in 1947, which obviously revolutionized electronics. I didn't know that. They developed the information theory, so a person called Claude Shannon. They created the C programming language and Unix, so the foundational to modern computing. And they pioneered work in lasers, fiber optics, and cellular technology. So,
Small stuff. Definitely.
small stuff that has major impact across the globe today, right? Like, I'm so glad they developed fiber optics, right? We all love a decent internet connection, right?
Yeah.
So I don't know about you, but like even CodeToCloud has CodeToCloud Labs, right? I just love the name Labs, right? It's a bit of a legacy term, but I just love it. But like, if we think of Bell Labs, right? It's a culture of deep research, practical engineering. It shaped much of today's computing and networking infrastructure. So many of its alumni, hopefully I've said that right, became legends in computer science. So even when those people left Bell Labs, right, they became like the founding fathers, right, of computing science, right?
Yeah, they are well known around the world.
But sometimes failure is the best fertilizer for innovation. Couldn't be a truer statement. So let's talk about Unix, right? So we talked about Multics, there was Project Mac, but Unix was the elegant reboot. So enter Bell Labs. So we're talking late 1969, Ken Thompson, Dennis Ritchie, and Doug McIlroy, hopefully I've said that right, and Joe Asana are relentless. They've tasted the promise of Multics, and they want something leaner, something elegant. So they start tinkering with a dusty DC PDP-7 in the corner of the lab. I can only imagine that this thing is like some humongous cabinet, right, with a green screen terminal, right?
Definitely.
So they call it Unix. So not like Unix is like UNIX, but UNICS. And it's a cheeky nod to Multics. Where Multics sprawled, Unix whispered, do one thing well, small programs, composable through pipes, text as a universal interface. So like we didn't even standardize on text being the output of the visual, like the data in or data out, right? Or even the visual like display language, right? At this point. And simplicity was a form of power. I say it over and over again. Don't over engineer something if you have to in tech, right? Keep it simple.
You mentioned something about the output of the text being text. It does ring a bell to me, if I recall correctly. The early way to output something from programs was through printers, right?
Correct, right? So we still send the movies, and you got the line printers, and depending on what you've seen, the noises and everything, right? And it was on that green and white paper, and it would be line by line, right? And someone would tear a piece of paper, and I've got the configuration in my hand, right? I've got the output in my hand.
Exactly. I'm thinking about our younger viewers. Even personally, I didn't ever see that, only in movies.
Totally. Then comes a master stroke. So in 1973, so we're in the 70s now, Ritchie rewrites Unix in C. In C. This is the moment portability becomes real. So instead of rewriting the OS for every machine in assembly, oh, whoa, these were like rock stars, right? Like diehards writing in an assembly. You just port the compiler and a few low-level routines, and suddenly the operating systems aren't chained to hardware, they can travel. And that is something we take for granted to this day, right? So instead of it being developed for a specific piece of hardware, it's now become portable, and then you can run compilers to run it on a piece of hardware, right? So write once, run anywhere was born with Java, but it was also born with Unix as well. It's pretty incredible. So we're going to talk about the founding developers as a backstory here a little bit, just to give you some context, some color, what's going on. So Ken Thompson, he was the co-creator of Unix. So he designed the original architecture and implemented many core components, including the file system and the concept of pipes. Thompson's also developed the B language. I've never heard of that one before. And a precursor to C. That was a precursor to C, right? And everyone's heard of C. And there's obviously different iterations of C to this day. Dennis Ritchie, he was the co-creator of Unix as well. He was the inventor of the C programming language. His rewrite in Unix and C in 1973 made the system portable across different hardware platforms, and a breakthrough that shaped modern operating systems. So think containers. We've all seen the meme. It ran on my laptop. Well, that's what containers do, right? It can run anywhere, right? Same kind of concepts, right? And this was all the way back in the 70s. Then we had Doug McIlroy, so head of Bell Labs, Computing Techniques and Research Department. Sounds like a fancy title. I'm thinking, dark wood walls, a large room, lots of people smoking, dark lighting, right? Amazing furniture though. So he championed the philosophy of small programs that do one thing well. Sounds like anything we know. Microservice architecture in cloud native land. And introduced the concept of pipes. So enabling programs to be chained together. So a hallmark of Unix design. So yeah, again, think of microsystem architecture, right? And then Joe Osana, known for creating Trough, the text formatting system used for Unix documentations and manuals. His work helped establish Unix as a developer-friendly environment with strong documentation tools. So, in true fashion, everyone else was working on all the good stuff, right? I'm going to ship this feature or bring out this part of the operating system. But Joe was thinking about future developers that wanted to help contribute to this software stack, right?
And what makes it usable for users? The documentation, because we need to figure out how to use it. So it needs to be well documented.
I agreed. I'd love to know what Joe's first readme.md was. Even I don't know if it was called readme.md back in the day. It was obviously I can imagine it being like
just a TXT
Encyclopedia
file.
or Encyclopedia from Britannica, right? Where there's just volumes, right? This is how Unix works.
Yeah, probably.
Yeah. What a guy. That guy's a hero.
Definitely.
So why portability mattered? So before Unix and C, operating systems were well welded to hardware. So portability meant faster adoption across architectures. So PDP-11 to VAX to Interdata and easier collaboration. Again, concepts that we're using today, right? Code could move with people, and by the late 80s, POSIX, hopefully I'm saying that right, and Unix 93 would formalize this, but the portability ethos started here. So here's some trivia for you. So students everywhere devoured the Lions. So it's a commentary on Unix 6 edition, a legendary text that walked the kernel line by line, right? So can you imagine going to school, Maxime, and you're going to learn the kernel line by line?
I would have gone crazy, honestly. But that whenever you went to school in IT during that period, you wanted to go through that. it's something that comes from passion.
It's like a
You're,
rite of passage, right? As
yeah,
well. Yeah. I mean, I'd probably be the same. I don't know about you, but I'd be like, yeah, I'm down for this.
I would have loved the challenge if I was in that time, but I did something similar also in my earlier days of using another operating system that we'll talk about later on.
It's awesome. So the first branches, so Unix variants. So as with all pieces of software, people have opinions and styles, right? The running joke with Linux a few years ago, and we're going to get onto Linux, was there seems to be a new operating system every weekend, right? That was being released because people had different thoughts and opinions. So we're going to go to the late 70s. So Unix is everywhere and it starts to fork, right? So BSD, right? It's used very commonly. It's got a lot of love. So BSD stands for Berkeley Software Distribution. So obviously like the school, Berkeley. So a couple of folks, Bill Joy and the CSRG, Computer Science Research Group, I'm going to guess, at the UC of Berkeley, so the University of Berkeley, hack Unix. So they hack Unix, right, for researching and networking. And in 1978, one BSD ships on a tape with X-Editor and Pascal tools. Everyone's heard of Pascal, right? One BSD stands for, I love this, completely logical, First Berkeley Software Distribution, which was an early version of the Unix operating system modified and distributed by the Computer Systems Research Group. I got it right. I got the analogy right. I did my homework. So the CSRG at the University of California, Berkeley. So by 1979, 2BSD adds Vi. Oh my days. Vi is still used to this day, right? Like it's incredible.
And I love it.
I was a Nano guy, but I'm a Vi guy these days, right? Those Kubernetes certifications, you gotta learn Vi.
Mm-hmm.
And there was another package called CSH as well. Then FreeBSD brings Unix to VAX with virtual memory. So these campus tapes will wire the internet if you think about it. And we've got a bit of a picture here, right? So imagine, I wouldn't even say it looks like a communications cab that you would see in a traditional data center. Like one of them looks like two welded together, but it looks more like a telecommunications cabinet, right? So if anyone out there has worked like for an ISP or a carrier or anything like that, right? Or it's similar to like, power distribution cabinets as well, right? Those are the sort of sizes that we're looking at here. And I mean, this physical cabling, right? Can you see that, Maxime, in that picture? There's like there's like a cable rack in the back.
Exactly. All the cables, probably that rack was used either for power distribution or network distribution, and it was the hub and the termination point for hooking up many racks together to either another provider or their other rack that is configured the same way to simulate what will be at some point the internet. So to have a one,
So
I think.
yeah, I know, right? I mean, I'm not an expert in this, but I can only imagine a lot of this is serialized. Like the way that I'm going to call it the fabric, right? These connected is going to be very local at this point in time, right? If we think about
Definitely.
history, yeah. So I can talk to the next appliance or unit in the same cabinet as me, and everything looks hardwired in. Like there's a lot of welding. It looks logically organized. Yeah, I think the one on the we'll share these pictures in the show notes, but the one on the left hand side looks more like a 19-inch rack, right? But the one on the right is just humongous. So as we go through these different versions and spin-offs and forks, I see a bit of a common theme. I think with the earlier forks, we're seeing operating systems that are moving in a different direction to work on certain hardware. And then I think we get to more of a generalized state later on. So System V, so this is from AT&T, or the SVR1, sounds like a cool Cold War plane, right? Launches in 1983, adding in enterprise features and init scripts. Init scripts.
Oh yeah,
So
it's
later,
fundamental.
I just like I didn't realize it went back this far, right? That's why I'm laughing about it. But later releases merges BSD ideas, so proof that even rivals borrow brilliance. I mean, we see this all the time, right? Inspiration, as they like to call it. So we're going to talk about a little company called Sun Microsystems now. So Sun OS in 1982. Sun Microsystems builds a BSD flavored of, let me say that again, a BSD flavored Unix for Spark workstations. So the perfect for the workstation boom that will define the 80s. This is when folks started getting computers on desks, right, in their office. And again, you'll see this in older movies, right? But a little bit of a segue here. Have you ever watched the movie Enemy of the State? Maxime, Will Smith, Gene Hackman. Basically, it's 1998, 1999, and there's a hacker in it. And the guy's got Sun Spark 19-inch racks in his bedroom at home, and he's working on them, right? Honest to God, when I was a kid and I saw that, I was like, what are those? Because like from that point of view at that time, all I'd seen was Windows and x86 servers, right? Or PCs. And I started to see these Spark, and that's where like the inspiration for me to research Linux and Unix came from at a young age. Was like, what are they using over there? Right? Like it was different.
It's fun to see how culture in general, like movies, does inspire people to do something with their life that is totally. It acts like it's a spark.
Exactly.
And
Yeah.
it's not necessarily a play on words here, but it acts like a spark to try to go discover a subject in particular. In your case, it was literally a Spark server.
Literally a Spark server. I remember doing some internship work, and there was a colleague, and they were working on Spark and Unix, and I was more mesmerized by that architecture and those operating systems because the vast amount of power that it had. Right, it was, and we're going to get onto that a little bit. Right, so x86, DOS, Windows, all that good stuff, right? And it became mainstream. Don't get me wrong. But like these specific architectures were like powering like banking and global services and the stuff that you would never see because it didn't fail, right? To be quite, it was rock solid. So if you've ever typed PS or tail-f, you've touched one of these operating systems, right? So, I mean, even Vi, right? I think that was a great little tidbit there. So, I like to, I like to add bits of popular culture into our podcast. So, and I always spot things. So, it's obviously the holiday season here. It's nearly Christmas time. My favorite movie is Die Hard. It's my favorite Christmas movie. It's a classic. So, if we fast forward to 1988, and now we're getting to sort of point where I was born. Hollywood gives us Die Hard, right? John McClane, Bruce Willis at his finest, right? But I don't know if you've watched the movie, and sorry if there's some spoilers. It's basically a heist on a corporation. And there's a hacker in there called Theo, and he's tapping away on this terminal, and it's labeled BSD 9.2. And I'm like, oh, and they really go into town on it, right? Like black screen, green text. He's having the time of his life, right, on the central computing system for this building. And it's to crack the Nakatomi Plaza's vault. So they've got a big corporate vault for the fictitious corporation called Nakatomi. So it's a cool scene, but it's all pure fiction. I found out it actually broke my heart a little bit, right? But BSD was at version 4.3 then, right? So I'm sure there's people, right, that have watched that film over the years, and they're like, 9.2 wasn't even out there yet, right? That's not even accurate, right? And we've seen that loads of times in films, right? But still, like green screen nod shows how deeply Unix seeped into the hacker culture, right? So for moviegoers, it was just a prop, but for techies, it was an inside joke, right? And now I'm going to join that crowd of folks that says 9.2 wasn't even out there. Have you
I
watched
know.
Die Hard, Maxime?
Yes, definitely.
Okay.
And it's one of the movies who sparked my interest in tech because I was like, hey, I want
I
to be
want to be.
like that guy.
I want.
He's cool.
I know it's pretty wild, right? You watch that film, most people are like, I want to be like Bruce Willis, right? Or whatever. No, I want to be Theo because he hacked the safe.
I know. Be the hero who have problem with his wife. I want to be the hacker. It's way more fun.
All I'm saying is Theo didn't have glass in his feet, right?
That
That's all I'm
also.
saying. That's all I'm saying. He turned up with shoes. He was well prepared.
Exactly.
I mean, we all secretly want to be John McClane, but yeah. Okay, so that was part one, right? So from Multics moonshot to Unix minimalist elegance, and from campus tapes to commercial forks. So, stuff that was developed in research labs becomes commercially viable software, right? So the stage is set for our Act 2. So we're going to start talking about networking, freedom, and manifestos that will change software forever. So part 2, the freedom, forks, and the hobby that ate the world. We're in 1980 to 2000s, right? So this is more like me growing up, right? That's what we just found out from Maxime that I'm a bit older than him. So the 1980s weren't just about big hair and bigger mainframes. Could you imagine that coming in? Rocking one of those like Stranger Things hairstyles, right? Working on a mainframe.
Why not?
I mean,
You have style.
I know, right? They were about quiet revolutions brewing in campus labs and hacker dens, right? Because this is when, hacking started to happen more and more. Like the internet got released, right? People were hacking into things like NASA or corporations, right? So Unix had escaped Bell Labs and was mutating, right? So one branch would wire the internet, another would ignite a war over software freedom. I mean, this is something that's still going on to this very day, right? So a student in Helsinki, he dropped a kernel that would change everything. And I think we know where we're going to go here, right? So Berkeley BSD was wiring the internet. So the story picks up at the UC of Berkeley. It's 1978, and a grad student named Bill Joy is tinkering with Unix. So he ships one BSD on tape, not even floppy disks, right? Or anything like that. And with just a few tools like the X editor and the Pascal support, no one knows that this is the start of something huge. So by 1979, 2BSD adds Vi and CSH, the muscle memory commands that you still use today. And then comes FreeBSD. So we talked about this before. So bringing Unix to VAX with virtual memory. And suddenly BSD just isn't a campus curiosity. It's a performance powerhouse. I'm trying to do my Clarkson impression. So what's the big bang, right? Let's accelerate things, Kev. What's going on? So 4.2 BSD, 1983. It ships with the TCP IP stack. I'm like, okay, so if you don't know what the TCP IP stack is and sockets, imagine every device that's connected to a network or the internet has an IP address and uses TCP IP to this day. It also introduced the fast file system. So these just aren't features, they're the plumbing of the internet. So every email, every early web page, every FTP transfer. Are folks still using FTP, Maxime? Is that still a thing? Because I know we got like,
yeah,
yes, yeah.
it's still a thing. I don't think as popular as other ways of sharing files, but to share to some point to sometimes just to do some point to point or sometimes to make available some a directory, still usable.
So I'm going to put you on the spot here.
Sure.
What is the port for FTP? Can you remember?
21.
Oh, look at that.
But there is a dedicated port if you use FTP with SSL.
Is it 22?
No, that's a SFTP, if I
SSH.
recall.
Okay.
Because there's a difference between FTPS and SFTP.
I mean, we use blob now, right? Or even that, right? We HTTPS is rules everything, right? But so this is all owes a debt to Berkeley, right? These are like the core foundational pillars of everything that we do. So by 1986, 4.3 BSD refines performance, but drama looms. Dun dun dun. AT&T sues BSDI, and in the early 90s over code rights. So obviously people were using pieces of code from repositories they shouldn't be using, right? So the lawsuit chills innovation, right? So obviously back then this would have been, I wouldn't even say it was front page news, but it's IP, right? You know, we think about like even Microsoft back then. People would fight over software and proprietary software and copyright infringement over tooth and nail, right? Definitely in the 90s. Massive lawsuits, right? That would go on for years, right? So it chills innovation because people are like, well, there's a lawsuit going on. People can't work together, right? People don't know what the direction's going to be until, version 4.4 BSD Lite. So in 1994. So it emerges, right? So it's a form of BSD, but it's scrubbed of all the AT&T code. So they remove all the proprietary code. So that releases the seeds for FreeBSD and NetBSD and OpenBSD. I mean, FreeBSD, dude, like that's folks out there still use it, right? It's BSD's used a lot.
Yes. BSD is used a lot in a lot of places that you don't necessarily know. That's something that I was thinking about. A lot of people now are after mentioning that the TCP/IP stack of NetBSD and all the BSD-based systems is even better than the Linux systems, the ones from the Linux systems. So yeah, BSD is still way relevant right now for high performance networking stuff and even more.
Yeah, like network appliances. I would say a lot of financial platforms as well. So, stuff that's running mainframes, ATMs, that kind of thing, right, is all built off these stacks, right? So each one of those different versions, though, had its own ethos. So performance, portability, and security. So BSD didn't just make Unix better, it made the internet possible. So if we think about Unix, proprietary or research development, right, from the famous institutes or A&T Bell, right, that we talked about before. So BSD started to bring this to the masses. So the likes of me and you could download BSD, right, Maxime? And basically write I think networking is a really good one because if we think of networking appliance stacks, right, so to the folks that are listening to the podcast, like, what are you talking about, right? Switches, routers, firewalls, right? Multiplexes, whatever you want to call it, right? We're all built on these stacks, right? They need an operating system to be able to run these low-level compute appliances and have something. So, and then we're just going to fast forward a little bit, right? But yeah, when you think of BSD, think of dial-up modems. I mean, I had one. Don't know about you. I don't know, Maxi. Maybe you had cable.
No. My first internet connection was through 56K modem. Oh yeah.
Those were the days, dude. Those were the days.
Those were the days. However, you got interrupted. Your connection was interrupted each time that your mother wanted to to talk to someone on the phone.
I remember me.
You had to live with that.
I remember hearing my mom coming through on the internal speaker on my computer because like it was like making a phone call, right? So you'd hear it and you'd be able to hear like part of the conversation that your mother was having, right? And then it would start that do 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 do, and then she'd be going crazy shouting my name, right? Because she would know that the computer signal was going to come down the line, right? And like drive her crazy.
And I think also the older modems were literally you had to take the
set, right?
The handset and put it over a mic and speaker to be able to decode the signals that were coming out of the phone. I think it was for the lower speed modems though.
Like 14K, 28K. Because modems in the 90s, especially with 56K or 56.6K, right? Whoa, right?
All right.
Had a telephone jack on the back. You're right. There used to be like a conversion kit where you'd see someone actually pick up the handset, right? The receiver, put it on a special device, and that would be the modem was several different components, right? Or pieces of equipment, right? Just to connect you to the internet, right? So yeah. But I think we're coming up to our era now a little bit, right? With this episode. So hopefully I'm saying this right. But GNU. So what is GNU? I know, it takes me back, dude. Oh my days.
However,
Like,
it is still relevant now.
it's still
Now
relevant.
more than ever.
Do you remember going on your first forum or reading that first license file? Those were the days. And you had to use Vi to open the license file. Because if you were like Windows heads like us, your first like encounter into Unix and Linux was a CLI. You'd be like, okay, where's the desktop manager? Right? And you started poking around, right? Literally. Just so GNU or GNU, I think it's pronounced GNU. It's a manifesto and a movement. So why Berkeley wired the network and another revolution was brewing in Cambridge, Massachusetts. So in 1983, Richard Stallman, a programmer at MIT AI Labs, he had an AI lab in the 80s. So I actually looked this up. It is artificial intelligence as well, right? It doesn't stand for something else. So it's going all the way back then. He publishes the GNU manifesto. So what was it, right? So his mission was build a free Unix-like system and fight proprietary software that locks in.
It is quite something important to note because in the Unix environment, all the programs that were executable so often were proprietary, and it was an issue. That's why Stallman forward with GNU, and we will go in more details later on what he did. But it brought a lot of changes to the industry.
Totally. So if we like go rewind a bit, we're talking about like those lawsuits, and they were fighting tooth and nail in the courts because people now you can access software and information freely, pretty much, right, across the internet, right? There's mass networks, right? But back then, this would have been a huge tape drive, right? You couldn't just like make a copy for your buddy and put it on a USB stick. Somebody actually had to move that data from one location to another, right? And I could see why, we used, and when we talk about proprietary code, so if you imagine an operating system, it's got many layers, right? There's a communication layer, there's the kernel, there's a security layer, right? And they take one component of that across to another operating system. That's what they were like, disagreeing about. So if it wasn't for our man here, Richard Stallman, which we're going to talk about this GNU, but this is where open source software is born. So buy this guy a beer, right? So GNU stands for GNU's not Unix. Right?
I love that.
I mean, it's pretty cool, right? So it's a recursive joke, but it's got a serious point. It's because it was trying to tell like these big companies, we're not Unix, right? Straight away. So Stallman launches the Free Software Foundation in 1985 and writes the GPL. So is that the General Practitioner's License? Or
General Public License, if I recall.
General Public License. There we go.
And
Maxime.
Everyone listening to the podcast, remember those three letters. They are still relevant today. They are super important. It's
Totally.
the foundation of open source today and true open source.
True open source. And that was in 1989, dude. Guy was a visionary. So it's a license that flips the script. So we used to have to put like message of the days licenses. When you used to buy Windows, do you remember the little book that used to come? The little white book? And it was like a certificate of authenticity, right?
Oh,
But it was also your license, right? It was a physical book, right? So it was a license that flips the script. So instead of restricting sharing, so instead of restricting sharing, it guarantees it. So if you built a piece of software and you gave it the GPL, you modify the code, yeah, no problem. You just must share it back, and freedom becomes enforceable. So it actually becomes like, if we've got guardrails around proprietary software, this becomes the guardrail to ensure that it's shared. And if you take a bit, you give a bit back as well. This is where these communities, right, become, communities start emerging, right? And again, it's something that we take for granted this very day. So GNU delivers tools that become the backbone of open source. So the GCC, a compiler that powers countless projects. Totally, I know about that one. The GDB, so it's a debugger that saves developers daily. Emacs, an editor so powerful it's practically an OS, right? I haven't heard that one in a while, right? But yeah, totally.
yeah, it's a bit too complicated for me. I do prefer still VI.
Emacs is an operating system. And then core utilities. And this is the stuff that we use every day, right? So ls, so listed directory or file, cp, so copy and move. Everyday commands that you take for granted were all born out of this GPL and the Free Software Foundation.
Imagine those commands were proprietary first.
And then you try to give it away. Not in the 90s, dude. That just didn't happen, right? Like, and we'll talk about this, like, these big tech companies that give stuff away, like Google gave Kubernetes away for free to an open source foundation, the CNCF, right? The Linux Foundation in 2014, that kind of thing. It was unheard of back in the 80s and 90s and early 2000s, right? But GNU had a gap, right? So it was the kernel. So Stallman's heard project stalls. So the orchestra is ready, but there's no conductor. That gap sets the stage for a finished student with just a hobby post. Right? This guy becomes he's more famous for this than anything else, right? So GNU gave us the philosophy and the toolkit, but Linux gave us the heartbeat. So we're going to talk about Linux now, right? So it's August 1991, and on the Comp OS Minix news group, a 21-year-old student named Linus Trevolds posts, and I quote, "I'm doing a free operating system. It's just a hobby. It won't be big and professional like GNU, but it's for the 386 and 486 AT clones." Famous last words, right? So
I know.
x86 architecture, right? He's trying to bring Unix over to x86, right? And he posts that, right? Like a throwaway comment. But those are his famous last words, right? So in September, Linux 0.0.1 drops. It's rough, but it works. And by 1992, Linus adopts the GPL version 2 license. So he open sources it, right? Effectively, letting GNU user land and Linux join forces. And suddenly the world has a complete free Unix-like operating system. So like within the space of a year, the guy builds his own kernel, right? In his dorm. And then he open sources it straight away and gives it away.
Yeah, because he just wanted to do something that was working the way he wanted to. It was like, oh, there's nothing available already for that. I'll just do it myself.
So
and
yeah,
that's how it started. It's crazy.
And so GNU and Linux join forces, right? So the free Unix variant or not Unix and Linux join forces. So then we get like the distros that start to bloom. So distros is short for distributions. So in 1993, we have Slackware, the first widely used Linux distribution. That takes me back. Also in 1993, Debian community driven, stability focused. Dude, how many Linux operating systems are backed by Debian now, right? Debian, right? It's like Ubuntu, that's obviously Debian itself, Linux Mint, Pop OS, many, many more. And then this is something that's close to my heart because this was my first trip. The mighty Red Hat, right? And every you ever speak to Red Hatters that make me laugh because you say, "What do you do?" And they say, "Well, we sell open source software." It's the running joke, right?
And in the
But
past, selling something that is free, isn't that, it's not conceivable.
it's not, right?
There's no market for it. But actually, there was a market. We'll see. But it's the business case around how to sell it. It's important to know.
I mean, they sell engineering support wrappers, right? Like you can adopt this open source software, but you're probably going to need some help, right? So they were pretty forward thinking, right? Development time, that kind of thing for your organization. So Red Hat, right? 1994. Shadow Man. Do you remember I think we got the logo here, but Shadow Man was like the mascot for Red Hat. And pretty much on every Linux magazine that you would see in the newsstand or wherever, right? Or your Walmart, wherever you went, right? There was always something about Red Hat in there. So Red Hat was the first enterprise ready, right? So think of RPM packaging. This takes me back to my teenage years. So Linux leaps from hobbyist circles to server rooms, right? So it's not just like me and Maxime at home building our Linux rigs, right? It's jumping to like enterprise stacks. And by the late 90s, it's running on web servers, it's powering ISPs, and creeping into the enterprise. Then comes the money shot. Red Hat IPOs in 1999, and stock prices quadruple on day one. And open source isn't just an ideology anymore, it's a business. To your point, Maxime, this is huge news, right? So it's no longer forums or news groups. This is a company that's, contributing to the stack, but also advocating for it as well, right? From a commercial point of view.
And thinking about that also, the fact that you have a company that also offers support on hosting services and web servers, it's also a way that the 2000s web bubble started.
Totally. Everybody wanted a web server, right? We think of Apache, that kind of good stuff. But everything was on, and to this day, right? We work with customers every day, right? But when they say, which Linux stack should we use in the cloud? There's only ever two choices for me, right? It's either Canonical, right, which is the Debian base, such as Ubuntu, right? We're going to talk about, or it's Red Hat.
Exactly.
That's it, pretty much. Do you want to talk about this bit? Because I feel like this was big news. Because it's about IBM, right, in Red Hat.
In 2019, there was a huge acquisition in the IT world. IBM bought Red Hat for $34 billion, which is really a huge move in the industry. It's a huge bet on the fact that Linux is the backbone of the hybrid cloud. We all know that IBM do sell their own, do offer their own cloud, but it's even so, through Red Hat, they are doing a lot of partnerships with many providers to make sure that the Red Hat solutions are being offered to everyone equally, and they can use those tools to deploy everywhere. I'm thinking about also Ansible in this case.
Totally, right? And so it wasn't buying the code for Red Hat or Red Hat Enterprise Linux. It was buying the open source culture. Like their engineering culture there is some of the best in the world, right? And it's built into the culture, but everything's still GPL licensed. Okay. I mean, IBM also bought HashiCorp as well, right? So we talked about Ansible there, but they bought Terraform as well. That is definitely a subject for another episode of the podcast.
Definitely, because otherwise we would start again for maybe an hour or two just to talk about that.
Exactly, right? So here's some trivia for you. So Linus originally wanted to call it FreeAX. An FTP admin uploaded it as Linux. So the guy had another name for it, right? Or FreeAX. I say FreeAX, but it's FreeAX, right? And the FTP admin renamed it. Oh, you gotta love naming standards, right? Literally.
Yeah, but though sometimes there's happy accidents, and we have now Linux.
Yeah, exactly, right? So history turned on a file name. Love it. FTP admin looked at it, nah, I'm not putting that in there. No one will know what it is, so I'm just going to call it Linux. Well, this is amazing. I love the tidbits coming out of this, right?
But it's really human for as a story. There's always some small mistakes. There's always conflicts. There's always some small events. We all have that in our lives.
Totally.
And it all reflects on the story of a product or multiple products or even an ideology.
I mean, we've done it together, right? We've worked on code together, and I mean, I've got to admit, Maxime's he's probably a better developer than I am, but
he's better.
He's like, why have you done it like this? Why have you called it that? And then, and I'm like, well, what do you mean? And then he always shows me a better way, right? But that's exactly what happens, right? It's interpretation, style, approach, everything.
Exactly. And my style is not the same style as someone else. Someone who appeared on your podcast, I think often, Gil Lima. Totally. He does have another style of coding than I do. And we sometimes argue about that. It's been quite some time though, but we did in the past.
Collaboration's everything, right?
Exactly.
We like to call each other out on our
But that's the basis of open source right now.
That's
and
totally
it was in the
how it
past.
works. Do you know what though? It raises standards, innovation. That's the way you look at it, right?
Exactly. Because we all want the product to get better, want the product to move forward. So by collaborating, by challenging ourselves and each other, can get something that is used everywhere as much as possible.
Totally. So, and this is something that we're moving on to a new section here, but this is something that I read a lot about in my high school years and college years. So, the OS wars, Microsoft versus Linux, right?
Mm-hmm.
It all turns out well in the end, folks. Trust me. But this was brutal at the time, right? So success breeds rivalry. And in 1998, the infamous Halloween documents leak internally from Microsoft memos calling Linux a credible long-term threat. They outlined strategies to fight open source, from FUD to embrace and extend. So publicly, Microsoft dismisses Linux. It's a bit of a call it publicity campaign, right? But privately, they're worried, and for good reason. Linux is eating servers, BSD's powering routers, and the web is exploding. And the OS wars defined the late 90s, right, and early 2000s massively. So Windows versus Unix, proprietary versus free. This seemed to be everywhere, dude. I remember just being on the internet and you'd read an article, right? Or like I even remember, I was trying to research security even back then. And people were like, yeah, the problem is with open source software is there's no contract to back it, right? In terms of security updates and that kind of thing. So you need to use proprietary enterprise software. And that's still a thing to this day, right? But that was the kind of like, conversations that are happening, right? In terms of in the community.
The amount of flame wars that I've witnessed and unfortunately participated to.
Obviously.
Yeah. There was so much on the internet, either about security or even which OS is the better one. Which OS is the best? Yeah, we all participated in that, I guess.
Totally. And there even was like flame wars on the distribution that you used as well inside the open source community as well, right?
Oh yeah, there was the front of open source OSs versus Windows, but afterwards, internally, there was the debate of, oh, which OS is better? Which distribution is better? Was it Ubuntu, Debian, Slackware, Arch at some point in the most recent history?
So Arch users are now flaming Red Hat Ubuntu users. Right.
Don't start that kind of flame war in the comments, please.
Dude, I can imagine the comments now, right? Our friend Jacob as well, he's a bit, I can only imagine. I think I said to him I was going to give him a laptop with Ubuntu on it, and he just looked at me like I love Ubuntu. Like, I really do. I don't know what his beef is. Anyway. So the battle lines are drawn, but for the next decade, we'll flip the script in ways no one will expect, right? So by 2000, the world looks different. BSD has wired the internet. GNU wrote the rules of freedom, and Linux went from hobby to IPO darling. And Microsoft, well, they're about to pivot in a way that will shock everyone. And it really did. We're going to double down on this, right?
Mm-hmm.
But first, a new player enters the stage, and it's Ubuntu. And it's a quiet victory that puts Linux in the billions of pockets. Right. So we're on to part 3. So the new millennium arrives. This is pure Kev on the internet. Like, kind of like, I'm on the internet. I'm joining IRC channels, right? And I know, right? I'm taking us back then, right? I'm joining forums and I'm trying to ask people on the internet to teach me about open source software. So maybe this is the decade, right? Linux lands on every desk. There's a bit of a running joke in that, by the way. But the real story won't be written on desks. It'll be written in pockets, data centers, and surprisingly, in handheld consoles, right? So the age of Linux is here, and you don't always see it because it's everywhere. And this is so what happened, right? So you had Apple and Microsoft on every PC in the world, right? Microsoft more than anybody, right? Windows was everywhere, especially Windows 2000. Like, when that came out, I don't know about you, but every school, every education institution, every business was running Windows 2000, right?
On my end, in the school I went to, there was only 2. It was the Mac PCs that were colorful.
Like the Perspex ones, like you could see inside a little bit, like
Yeah.
the case. Oh, they were gorgeous, right? They were like green, and I think there was like a pink one, but it was like a small TV. It looked like a small TV, right?
Everything all contained within the same screen. It was really a beautiful computer, but there was only 2 in the schools. Otherwise, everything was
Windows, right?
Windows based.
Was that the iMac? Did they call it the iMac then?
I think so. Honestly, I'm not well versed in the Mac,
Apple,
old Apple ecosystem, since I was mainly a PC user, even in that time.
Dude, sorry, this is a story for another podcast, but yeah, I'm an Apple convert now. I really am.
Now, me too.
Could you imagine your teenage self looking at you now, right?
Honestly, I wouldn't have believed it. Someone who's an Apple convert working at Microsoft, but when I was younger, I was and still is an open source advocate.
Totally.
My younger self would have seen me as someone who strayed from the right path. But no, instead, I'm following the right path.
Exactly. It all worked out, right? Which is, So let's talk about, I know you're a fan of this distribution, but let's talk about Ubuntu, right? So it's Linux for human beings. And I think Ubuntu stands for tribe. I swear that was like a translation in the box. And me and Maxime were talking about this just before the show. In 2004, a South African entrepreneur and engineer named Mark Shuttleworth has a simple, audacious idea to make Linux as approachable, but not just as powerful, but pleasant to use as well. Because this was a running problem, right? in distro land. So he founds Canonical and launches Ubuntu. And with a predictable 6-month release cadence and a long-term support to LTS every 2 years. So Ubuntu's pitch was more than just packaging, because he really did. He wanted to like humanize it, because when you first got your first entry into Linux, I don't know about you, Maxime, but I remember getting that Red Hat CD, putting it on my computer, right? I had Windows ME at the time or something, right? And then putting Red Hat on, and nothing worked. Sound drivers didn't work, different hardware peripherals didn't work, right? It was a bit of a slog, and it was, in most cases, it was a vertical learning curve, right? Because there was no click to install. Even though we had desktop managers, you had to do a lot of stuff in the CLI, and you had to compile kernels and everything else. Stuff that we take for granted today, right? So Ubuntu's pitch is more than packaging, it's polish. So same defaults, again, that's another running joke in the Linux land, right, today. You know, a friendly installer, a good hardware detection platform, and a community that smiles when you ask questions, right? We'll talk about that shortly, right? Instead of gatekeeping the shell. And suddenly you can recommend Linux to a friend without a caveat, right? So for many developers, Ubuntu becomes their first distro that keeps, not just a test. I remember joining, I think it was like linuxforums.org. I may have got this completely wrong. And asking, they used to call me noob, right? And they'd be
That
like,
does happen.
yeah, and it was really like everyone expected you to be an expert, right? And like they didn't realize they were talking to a 13 or 14-year-old kid, right, from England, right, trying to figure out what this was all about, right? I've got to say, the community has come on a long way now. Like,
Yeah,
you can find people all over the place. There's chapters, there's meetups. It's absolutely awesome, right? But back then, I don't know about you, Maxime, I remember like posting like, how do I do this? And just getting destroyed, right?
exactly. And as you mentioned, we were young people. So even we weren't that great yet to ask the proper questions. And then we would get destroyed. Or now I would say we were getting a thought to ask the questions properly and put more documentation within the issue that we were raising. And honestly, yeah, it's been quite of a learning experience to be in those kind of forums. I do recall those days. It was really fun to order the CD to get your distribution installed.
Right.
You had some issues, and then you would go on the forum on another computer to figure out what happened.
Right.
And it was even crazier whenever you wanted to install, for example, Ubuntu on a laptop. It was something else. Because it was easier to install on a desktop because there was no issues with the wireless drivers and stuff like that.
Oh, you're taking me back, because it was the VLAN driver, right? All the time, right? You'd have to go in, because wireless networking, right, was, I mean, it was problematic in Windows. You used to have to install additional software on top of the operating system to manage Wi-Fi networks. It wasn't built into the Windows stack like we know today, right? It was even painful on Windows, right? And drivers weren't reliable and everything else. So when you jumped over to Linux land, it was even harder, right? And
You
do
had
you
to
remember?
recompile the kernel.
Exactly, right?
That's how you learn. At least for the people, at least for me, it was how I learned how to recompile the kernel because I had an issue with the wireless drivers.
I just remember going, what's a kernel? And then Googling it. And that was basically it. And then it was like, I learned so much though. So much. Concepts more than anything. Because at that point, in Windows, it was all hidden away. You'd switch on your computer and you'd get the amazing boot screens of the 90s versions of Windows, right? Or the early 2000s. And then it would just launch straight into the desktop, right? And away you go. Whereas most Linux distros were like, there was a bootloader called Anaconda, and then it would move on to boot in the operating system. And that would be, and you used to get like a list. and it used to say green pass or red fail, right? And it would just stream verbose logs, right, on your screen. But you'd learn stuff like hardware abstraction layer. And basically the operating system was raw, right?
Yeah.
So when anyone asks me, what should I learn as a skill? Like, you should learn Linux, like straight away over everything else. Because it just gives you, as we've talked about in this episode, there are core foundational pillars that it'll teach you. Commands, communication, architecture, development techniques, the works.
You have the freedom to do anything you want using a Linux system, and you don't have to follow the guardrails that are imposed to you. So if you want to do something, I would say sketchy, you can do it. You will have to suffer the consequences of what you're doing, though.
Yeah, it's like you can take the airbags out of your car, but it could be a problem down the road, right?
And that's how we learn.
That's how we learn, right? So Ubuntu didn't make Linux easier by dumbing it down, because that was an opinion. It made it more welcoming by design. And I feel like, and this is something that I've had opinions on over the past couple of decades, was if we look at like OS X, Windows, now macOS, right, from OS X, they're opinionated operating systems. And the thing is with Linux, which was one of its strengths, was also one of its weaknesses, was it felt like there was a new distribution being built every weekend because somebody didn't like the way that the desktop looked or how the operating system loaded. And the problem with that is democratization became anti-efficient in terms of adoption, which really, created hurdles. So like, if you think about, like, we were talking about the enterprise stack and servers and network appliances, like people standardized on Red Hat, right? Whatever. And that's why it was winning in the server space, right? Because it was opinionated. But then if we get into the mid 2000s, so then the quiet victory is that Android wins the phones race. So while the desktop remains a dream that comes and goes, and you'll see it, you should see it in the next couple of weeks in December, it is 2026, the year of the Linux desktop, right? It's a bit of a running joke.
Yeah, always.
It is, right? It's a bit like Half-Life 3 is going to be released, right? It's that kind of Linux wins where no one expects it. Phones. So in 2008, Android launches, and it's on top of the Linux kernel. It hides most of the Linux userland with its own stack, but the heartbeat underneath and is unmistakable. So within a few years, Android becomes the dominant mobile OS. It really does. I know Apple, well, we're all iPhone users here, trust me. But it just seems to be like you can release a cell phone on a piece of hardware and have Android on it, right? Because it was open source. So billion scale adoption turns Linux into the platform you touch. So dozens of times a day without even thinking about it, right? I'm using Linux. So you think about tablets, cell phones, everything at this point, right? It's all running on Linux.
And think about where you have Android now. Not even just on phones. You have also on point of sales, which are basically tablets. You have it a bit everywhere. And then it runs on Linux. And honestly, even if we are two Apple aficionados, competition is always a good thing.
I love it, dude. Like, I always think about the space race. There wasn't competition, right? We wouldn't have the technology we have today, right?
Exactly.
Think of your car, TVs, microwaves, fridges.
It all runs on Linux at some point.
All runs on Linux. I mean,
since it's getting smarter and smarter.
Yeah.
They are getting smarter and smarter. Yeah.
Don't get me wrong, there are pros and cons to that. I am the kind of guy that goes, I don't want a computer running my fridge. I just want the fridge to work, right? But it's all Linux powered, right?
Exactly.
So here's a bit of a tidbit for you. So Android's Linux kernel is a heavily adapted of SE Linux. So I think it's security enhanced Linux, right? Because this takes me back to my device management days, right? When it was one of my jobs, right? Securing devices. So SC Linux policies, binder IPC, and special drivers tailored for mobile and battery constraints. So imagine, right? You can't just dump the desktop version of the OS on a cell phone. You'll drain the battery you're gonna have smaller hardware components, different types of memory, all that good stuff. Has to be built for mobile devices in mind.
And you brought a good point. Hardware compatibility. You don't. I do know that there was an experiment from Intel, if I recall correctly, of having x86 processors for mobiles.
That's right.
But
Yeah.
the fact that Linux, the support for ARM was already, Linux was already compatible with ARM components, it made the transition easy for Android to just use the Linux kernel, since it was doing already doing the conversion and act as an abstraction layer for the hardware with ARM. It was easy for them to build upon that.
Totally. And ARM's used everywhere now, right?
But yeah, even now it is a bit more different the way Apple
But yeah,
is managing the way they are using ARM, but you do
Apple
see
Silicon.
the Apple Silicon. I'm thinking also about the Snapdragon cores that we have almost everywhere, even in some Microsoft devices. Honestly, there's a lot of company that licenses ARM cores. So yeah, it is now everywhere, and I wouldn't be surprised to see less and less x86 devices in the future and more ARM devices for consumers. But
feel
that's
like
another subject.
I agree though. I feel like we're in a shift. I think x86 is on a timeline. That's what I'm going to say. I think in the consumer world, I think we're going to move over. I think you're right. Tablet operating systems, cell phone operating systems are now becoming the norm. I think people are using less laptops. If I think about the amount of executives that I know that just use an iPad, right, to do their work, because that's all they need, right? So I think it's going to be more like the power user that's going to need more of a desktop OS moving forward, right?
And it's getting there already.
Totally.
I'm thinking about schools, the children who are using Chromebooks that, yes, sometimes are more, I think they are still based mostly on x86 hardware. But I think there's some ARM ones. Now I'm not that sure of that one, but still, it's coming.
So talking of Apple, so Apple's Unix roots, so from Next to your Pocket, that's what we're going to talk about next. So like we said, we're completely Apple converts, me and Maxime. It's really true, right? So think Apple's elegance, all of its gloss and design, the marketing got to us in the end, right? So underneath that polished UI beats a Unix heart, right? So a lineage that started decades before the iPhone ever buzzed in your hand. So the story begins in 1988 when Steve Jobs was fresh from leaving Apple. I don't think he left Apple. I think it was a bit of a hostile takeover from what I remember, right? Wasn't he like forced out the company, right?
I think so.
And wasn't it like a CEO of Pepsi took over Apple? It was something wild like that, right? Actually set the company back, right?
Oh, yeah, that's why he came back as a savior.
That's why he's revered to this day, right?
Yeah.
So he launches Next Step, right? Is an operating system built on Mac, microkernel, and BSD for Unix, right? So he leaves Apple and, he's building this new architecture. So fast forward to 1996, Apple buys Next for $429 million, right? And as part of that, they bring Jobs back. So he comes back as CEO, right? Adopting Next Step as the foundation for its next big OS. And I think it was like about that time you started to see those colorful iMacs that you were talking about that you saw at school. And they were everything about Apple is the design, even down to the operating system, right?
And it's crazy to think that basically Apple was that close to bankruptcy.
Totally.
Imagine how it would have changed the landscape right now if Apple wasn't there. Without the innovation that Steve Jobs brought to the company and then to the world. I'm not someone who reveres Steve Jobs as a saint. He's quite particular as a person, but we can't deny what he brought to the industry.
Diplomatic words there, Maxime. I know exactly where you're going with this, but yeah. his impact, was truly, truly amazing. In 2001, Apple ships Mac OS X, so it's a shift. And it's a radical reboot. I remember this because I used to go on the Apple website going, I really want a Mac because I'd see them all in these movies, but, there's a price tag attached to any Apple device, as you're well aware, right? And it's built on a stack called Darwin. So it's an open source core combining Mac. So MACH, like Mac is in Mac 1, Mac 2, Mac 3, right? Like the speed. And BSD, right? This wasn't just a technical choice, it was a cultural pivot. So embracing Unix, Apple gained POSIX compliance, stability, and a developer-friendly environment. So suddenly your Mac could run a terminal that felt like home to a Unix hacker. It's
And
true.
yeah, and also it's the basis of what made macOS that stable in that time, because we were always comparing Windows versus Mac OS X, and Mac OS X was really stable. It was, compared to Windows, was unfortunately always bugging out. There was always some issues. That's what made Mac OS X rock solid.
Because it was built on Unix. And they used to use that in the marketing, right? I used to read that. Yeah. Then came a twist. In 2007, iOS launched. Right? Not the Cisco iOS, the Apple iOS, two different things. It shares the same Darwin core, but every iPhone you've ever held runs a Unix-based kernel. So that means the device in your pocket speaks the same language as a server's powering the internet, right? It's incredible. This is what we're talking about, right? It's conquered everything, right? So Apple didn't just make Unix beautiful, it made it mainstream. And that quiet decision shaped everything from mobile apps to cloud workflows. This is the reason that me and Maxime have got jobs to this day.
Yeah.
So let's talk about containers, right? So there's the developer's new superpower. So then comes a tool that changed how software is built and shipped, containers. So around 2013, Docker popularizes a developer-friendly workflow built on Linux primitives. C groups and namespaces so you can package code, dependencies and runtimes are the neat portable unit. But it works on my machine, right? That's where it all, I've heard it all before. And it stops being a punchline and it becomes a contract. It really does. It really does. So the orchestrator for containers, right? Because people always get mixed up. Isn't containers Kubernetes? No. Kubernetes is the orchestration platform that runs your container. So in 2014, Kubernetes lands. Born at Google, quickly open sourced. So they give it away, right? I think it's to the Linux Foundation or the CNCF at the time, right? And it's the orchestrator of orchestrators. Scheduling pods, managing services, rolling updates, healing clusters. And in 2015, the Cloud Foundation CNCF forms to steward the ecosystem. So I think it was given to the Linux Foundation, and the CNCF is born out of it, right?
Because it was too big to manage.
It's too big to manage, right? The CNCF is something close and near and dear to both of our hearts, right? So from logging and tracing to service meshes and packages, registries, the cloud native world takes shape around Linux as a runtime and a common ground. So if you ever typed kubectl, apply, and watch containers spin up, you were standing on Linux. If your laptop was running Windows or Mac OS, even if your laptop was running Windows or Mac OS, right, you were interfacing with a Linux stack. So here's the twist, and this is where everything becomes great. Microsoft embraces Linux. So our CEO, Satya Nadella, we were talking about this before. This guy came in and fundamentally changed how the company worked in terms of working with everybody, right? No smashing of iPhones on stage, no calling Linux evil or open source evil. It became part of like our creed, and it still is to this day, right? If we think of Azure and our cloud platform, it runs more Linux and open source workloads than anything else. And that's only grown year by year as people modernize their architecture to cloud native stacks. So for decades, right, Microsoft was painted as Linux's rival. But then the developer world changed and Microsoft listened. And in 2016, it ships the Windows subsystem for Linux. I remember seeing this, dude, and it blew my mind, right?
I loved it. The first time it came out, I was like, finally.
I just couldn't get my head around it, right? So it was a compatibility layer that lets you run Linux userland on Windows without installing a full VM. So people used to dual boot, right, between Linux and Windows, right?
Oh yeah, I've done that for so long.
So in 2019, WSL2 arrives. That was awesome, by the way. So full integration with IDEs such as VS Code. I'm able to run containers locally. I remember Docker using it as a back end, right, as well. Like everything started to come together, right? It was absolutely awesome. Essentially it was a lightweight VM, and it would dramatically improve file I/O compatibility and system calls. I do remember going into Windows Explorer, and there'd be the little penguin on the left-hand side, and you could go into the Linux file system from Windows Explorer and copy files backwards and forwards. It was
mind-blowing. Just thinking, oh, it's now 2 operating systems, but I use it in one place.
So suddenly Windows laptops felt like a Linux workstation. So you got the best of both worlds, right? Because you'd have to buy a Mac for that.
Usually,
because if you wanted Office, right, or that premium desktop experience, but you wanted that Unix ecosystem, you had to get a Mac, right? So a Windows laptop felt like a Linux workstation whenever you wanted. Native tooling, apt.dnf, SSH agents, container workflows, all from your favorite Windows apps paired with VS Code with WSL2, right? It was your inner loop for development in fast Linux first and friction free. I remember just shifting overnight. I didn't need all these added applications. I could just SSH straight from my WSL container, right? And do everything that I needed, right? Development wise with WSL. Like it was awesome. So meanwhile, inside of Azure's platform teams and other change brews, Microsoft engineers a minimal hardened Linux distro. This was like major news, right? And I've interviewed the product manager for this, Jim Perrin. What a guy, right? So him and his team develop a Linux distro for Azure services and container hosts, right? It started off as being called CBL Mariner, right? And it matures into something that we know today as Azure Linux. So it's a small footprint of curated packages. I think it's like 70 or 80 meg. Rapid
it needs to be
update.
super lightweight.
Yeah, it's like so small. And it's consistent with AKS, right? So Azure Kubernetes Service, node images, and tight security posture. Because if it isn't built into the OS, you're reducing the attack surface immediately, right? Again, going back to those core principles of Unix from the 60s and 70s, right? So the company that once fought Linux now ships its own Linux OS, right? That runs on cloud native platforms inside of Azure. It blew my mind. And that's why I wanted to interview Jim. I think Jim came from Red Hat as well, right? Everything goes full circle, right? And Linux powers the cloud. Absolutely mind blowing, dude. How we've evolved.
Honestly, that evolution personally is what allowed me to go in Microsoft, because I wouldn't have thought about working at Microsoft if they was still aggressive against open source, because that would have been bad business. Because we know where the world is going.
Totally.
It's going the way of the open source. This is the way.
This is, as they say in The Mandalorian, this is the way.
Mm-hmm.
So if we think today, Windows versus Linux feels quaint. And the modern story, Windows with Linux, or Linux on Azure, or Linux for everything, right, is more of a standard approach.
One of my mentor mentioned there's no point of doing arguments about Windows versus Linux versus macOS. Just use the proper tool for the job that you want to accomplish.
I completely agree. It shouldn't even be a fight anymore. It's more like, here's a new piece of tech. Is it going to fit the bill?
Exactly.
So The development experience, the everyday bridge. So if you're a developer, the pivot was more of a press release in your day to day. You can spin up Ubuntu or Azure Linux containers locally in WSL2, test them against AKS. I'm a fan of AKS. You can spin up, you can use the same CLI flags, the same kubectl commands, the same YAML, you push to prod. Secret flow via Vault, log pipes into your cloud platform, and your terminal feels like home. So even on a corporate laptop as well. I mean, I use my Mac every day, right? I actually used Fedora for a while, but corporate security caught with me.
Oops.
So the bridge got even friendlier with WSLG. So this is when they released that mini, I'm going to call it a desktop manager, but basically you could run GUI Linux apps on Windows from the compositor bridge. So meaning that quirky editor or that toolkit from Linux first vendor can coexist with your Windows stack. I remember when they did that. It was wild. So the walls didn't just come down, they got replaced with a walkway, right? Essentially. So here is a subject that I love to talk about. When you talk about gaming, my friend, right? Because that's, I don't know about you, Maxime, but like, it's something that's energized my tech career, right? Was I started playing video games on PCs, right?
And I'll be honest with you, that's one of the reasons why I got into tech. It's gaming. I want to have, and also I wanted to optimize my latency with the games I was playing, that I was playing on. So I had to learn networking about that, knowing that plugging your computer into a hub and you have multiple computers plugged into the hub will cause problems. And then switching that to a switch. Honestly, that's what brought me to IT, in addition to the movies we mentioned earlier on.
I completely agree. Like, if it wasn't for Doom and Command and Conquer, dude, I don't know if I'd be sat here, right?
Exactly. And Command and Conquer, that's the game that I wanted to have less latency on.
So while clouds were getting bigger, something curious was happening in gaming, right? Because like when we were growing up, it was all about DirectX, right? So that was a Microsoft runtime stack that gaming developers could use to interface with graphics card chipsets, right? And I think one of the biggest ones was DirectX 9. Half-Life 2 got released. I remember bringing it home and none of the shaders would work because I didn't have a DirectX 9 graphics card. But it was like major news because the amount of innovation and graphics fidelity it brought, right? By this runtime. And you couldn't run games on Linux. And if you did, it wasn't a similar experience than when you played them in Windows, right? So in 2018, Proton arrives. It's a compatibility layer, so it's Wine, DXVK, VK D3D, and Proton. And it translates DirectX calls into Vulkan for Linux. Suddenly, thousands of Windows titles start just working on Linux. You know where we're going with this.
And before, if you wanted to have a game that was, if you wanted to buy a game that was compatible on Linux, the game has to be had to be created on OpenGL, using OpenGL. That brought a lot of other issues if you wanted to have that game on Windows systems.
Do you remember Unreal Tournament?
Oh yeah,
It had two modes, OpenGL or DirectX. And the DirectX mode was better than the OpenGL mode, right? Because
yeah. I think it was the same also with World of Warcraft, or
yeah,
I do recall seeing some people playing that game on Linux, but I don't know the amount of hacking that was done behind the scenes to make it work. Because it's not my type of game, but I do recall seeing that. It's crazy.
So in 2022, Valve releases the Steam Deck. It's a handheld console running Steam OS. It's on Linux. I think it's on Arch Linux. I think it's based on, actually.
I think so.
It's a custom AMD APU, and the UX is slick. So you've got like the Valve library, the Steam library. Sorry, Steam has a lot of respect from gamers in the PC world. I mean, I've been on Steam since 2005, I think. I've got one of those founders badges because Half-Life 2 got released and you needed a Steam account. So the Steam Deck obviously does very well. People are really shocked, actually, right? because I think something similar. You only have like the Nintendo Switch, and the PSP hasn't, the PlayStation Portable hasn't been re-released in years, right? So developers start testing their titles against Proton. And I think there's even like a library where it tells you now, you can go on this website, I can't remember what it's called, but it'll tell you how well a Windows game works on Steam OS. It's like, and how well it works on a Steam Deck.
I think it's Proton DB.
I think
Or
it's
spelled
Proton.
correctly.
Yeah, I think it's Proton DB, right? Players found the library was huge and growing, and by late 2025, Linux usage on Steam, powered largely by Steam OS devices, nudged past 3%. This is incredible, right? This is like major news, because now we're starting to see it eating the desktop pie. Even though it's a handheld in your hand, this is how you get people to come on board, especially game developers. It's a cultural milestone, it really is. So for many, the Steam Deck becomes their first daily Linux computer. It's pretty wild to think about it like that, but it's true. So you plug into a dock, becomes a desktop, you undock it, it's a games console. And Linux disappears in playtime, right? So, which is exactly how mass adoption usually looks like. It's invisible. You think of the iPhone, didn't realize it was built on Unix. Mass adoption. So the Steam Deck's success wasn't just hardware, it was Proton's continuing improvement, right? So there's a demand there, more people get on board. So the GPU driver work, Vulkan's rise as a fast portable graphics API.
Shout out to Valve's team. They did an exceptional work. And the fact to get to the point of releasing the Steam Deck, it took a lot of work. I do recall I was on the beta of Steam for Linux when it came out.
I remember
in
that.
2012. I think late 2012. I remember being in my first apartment and just geeking out and be like, wow, it's awesome to run Steam on Linux. It's so great. I was playing Left 4 Dead 2 and enjoying the fact that it was running on the operating system of my choice.
It is a big shift. And I think to your point, I remember playing Half-Life 2 on it, and I'm like, it's not on XP. Because that was my memory, right? Playing that game was on Windows, right? It's now, I think, yeah, to your point, Steam or Valve went and rewrote a lot of their titles, right? To try and lead the way, right? Like adoption takes time. So, shout out to those guys.
And it's been what? 13 years?
Totally.
About. And it's paying off now.
So I believe Father Christmas is getting me a Steam Deck, right? I'm very looking forward to it. I really am. And they just announced the Steam machine. And I honestly think, it's going to be a swap out for my Xbox completely. I do.
Honestly, and why not?
Why not, right? So, more gaming. Because, like, we were talking about devices that everyone uses, right? So, we're going to talk about the PlayStation.
Yeah.
It's the most successful console, right? Of this generation.
For many generations, it was, especially if we look at the console wars per se. Otherwise, there's always Nintendo doing their own stuff, doing innovation on their end.
It's kind of weird, right? Because Nintendo's always second place. That's what I always see, right? But their games and their audience is different, right? If we think of PlayStation, Xbox, I think of Call of Duty, right? Or I think racing car games, or
Final Fantasy, JRPGs,
Resident Evils, the Metal Gear Solids, right? They're on, Nintendo was designed for kids, right? Family markets, right? It's fair to say. So let's talk about the PlayStation for a second, because Sony's PlayStation isn't running some mysterious proprietary OS. It's actually built on Unix. And you could install Linux on the PS2 and the PS3. I think it was called Yellow Dog Linux. You get a keyboard and mouse. Problem is then people were hacking the architecture on the PlayStation. We used to call it chipping, chipping your console, right? In Europe, I don't know if they called it here in North America, or modding, right? Modding, right? It's probably what it was called here, but they took that feature and functionality away, right? Because they didn't want you having access. But the PS4 era in particular, it's something called Orbis OS, and it's built on FreeBSD. So it's a Unix-like system known for stability and performance. So that means every time you boot up your PS4 or PS5, you're touching technology that traces back to the Berkeley BSD tapes all the way back in the day. Playing that latest game of Gran Turismo or The Last of Us, thank Berkeley Technologies for that for you, right? Those researchers. But this is, Sony PlayStation 3, yeah, shipped with an OS feature that enthusiasts will install Linux or FreeBSD. It had a kit and you can get a keyboard and mouse. That's pretty crazy, right? So in your living room, yeah.
And if I recall correctly, with that feature, there was a public organization in the US who made a cluster out of PS3s
for research, right? Because
it was using a great PowerPC CPU.
Cell Broadband Engine, it was called, right?
I think so.
This was an IBM PowerPC architecture. This was great, Maxime. I don't know if you want to talk about this a little bit more, but effectively it was like this thing was like overpowered, right? Like the architecture, everything. But the problem was it was an absolute nightmare to develop for. And this is what gave the 360 its advantage, right? Development tools.
That's why the people for research were using that kind of compute power, because it was a lot of compute power for a really small amount of money, especially for the time.
I remember actually, I think there was a feature that you could enable on your PS3, and it was like, do you want to donate? Do you want to leave your PlayStation on, and it will help research for medical scenarios, right? I swear that was a feature.
I don't know about the PS3, though. I do think it still exists now for PCs. I don't know what the program is called.
Forgot what it was. It was like a feature in the OS, right? But yeah. So why does this all?
It's the Boink app.
Exactly, right. So why does this all matter? Because it shows how deeply Unix principles, portability, modularity, and stability permeates even entertainment tech. So from servers to smartphones to your favorite console, Unix isn't just in labs or data centers, it's in your living room, powering epic boss fights and cinematic adventures, right? You think about it. Playing that next game of Metal Gear Solid, boom, it's on Unix. So the next time you fire up your PlayStation, remember, behind the controller clicks and loading screens is a system built on decades of Unix wisdom. And that same DNA is running in the cloud that streams your games. It's pretty epic if you think about it.
Imagine the amount of people who worked on the infrastructure and even on a game. There's a lot of people working on a game. Imagine all the people it took to build the ecosystem around allowing you to play your game in your living room.
Wild.
There's a lot of people. There's a lot of investment of money, investment of time. It's crazy.
So we're going to close this out, but we're going to ask the $1 million question. And I'm sure I'm going to get a laugh from Maxime. So, Maxime, will 2026 be the year of the Linux desktop?
Since I'm someone who's really optimistic, yes. And I said that for all the last few years.
Same here. I think I've said it the last 20 years as well, right? I mean, it's conquered everything else. Servers, phones, cloud runtimes, held-hand gaming, Sony PlayStation consoles. And on the desktop, the shares keep climbing. I really do feel like the Steam machine is going to put a dent in it.
Oh, yeah. Since it's everything that is already well packaged, ready to use, and you don't see any complexity. That's the key. You are really far of using a distro that you downloaded on the internet and recompiling the kernel. Everything just works ideally.
So here's a closing fact. for you. Linux is everywhere, even where you least expect it. Today, Linux powers 96% of the world's top 1 million servers, runs on every Android phone, and forms the backbone of cloud platforms like AWS, Azure, and Google Cloud, even on the International Space Station, dude.
On something stable.
Yeah, you don't want to reboot. Life support systems down.
Whoops.
What happened? We had to reboot. Oh, and it's the kernel behind most AI research as well. We think about it, right? We can only imagine what the folks are doing down at ChatGPT land, right? Or Anthropic, right? I'm sure it's all built on Linux. I know machine
Definitely.
learning, data science has been built on Linux for some time now, right? So it's absolutely crazy, dude.
And most of the banking system also is based on Unix.
Totally. Especially those IBM mainframes, right? Out there. They're solid.
Linux and Unix system does have a large impact on our lives, and we don't know about it. It's mind-blowing.
So that comes to the end of this special episode on the history of Unix, Linux. Maxime, any final thoughts?
Any final thoughts? I think what I would say is, if that's something that interested you, continue to explore and learn about it. It's really great. I would personally look into, if you're interested to that, look into the mission of Ubuntu. The people over there are doing great stuff for the community and for the education sector. Honestly, just keep learning and see how the work of few people have impacted your life.
That's awesome. I'm the same. How do we make things more accessible for folks, right? In terms of education. And I feel like it's one of the principles around open source software as well, right? It's community, accessibility, information sharing. But yeah, like, look, we went through a lot today. Hopefully you enjoyed it. I know me and Maxime have. Don't forget to join the CodeToCloud community. You can head over to connect.codetocloud.io, join our Discord, and why don't you share your favorite Linux distro with us, or your favorite Linux or Unix story, right? With us, right? On the Discord. I'm sure the community would be more than happy to hear it, right? There are no flame wars on the CodeToCloud Discord. Maybe I mean I get a lot of heat for using a Mac, right? But it's all in jest. But yeah, thank you very much. If you like what you've listened to, don't forget to like, share, and repeat. And we'll catch you on the next one. I'll see you for now.